Do you know that the sky above our cities is becoming an extra lane? On 30th of August 2025, NeuroDriveAiReels asks, do you know how flying cars and air taxis are being integrated into busy city airspace? This isn't science fiction. It's regulated air corridors, air traffic grade autonomy, and the same safety principles that keep jets aloft, squeezed into urban skies. The first challenge is predictability. Ground traffic follows lanes. Air traffic must do the same. Cities testing air taxis build sky lanes, vertically stacked corridors controlled by a central traffic manager. Think of them as highways in the sky, painted in sensor telemetry rather than asphalt. This architecture allows hundreds of small VTOLs to operate without chaos. Next is sensing. In the ground world, LiDAR, radar, and cameras suffice. In the sky, vehicles combine those sensors with ADS-B, like systems for position sharing, and redundant GNSS solutions to deal with urban canyon GPS errors. The result is a multimodal situational awareness that treats birds, weather, drones, and tall buildings as equally important hazards. Another, do you know? Japan and several other countries have moved from demos to regulated pilot corridors. These pilots gather real human behaviors. How do people queue to board an air taxi? How do city services handle emergency landings? That data feeds AI models that must think like an air traffic controller and a taxi driver at once. Integration also raises the human factor. People need legible signals, approach lights, landing pads with dynamic markers, audible announcements. Urban residents need reassurance that a VTOL overhead is predictable, not random. So designers build invisible intent, approaching lights that flash in patterns to indicate a vehicle's next action, descend, hover, or clear the pad. These UX signals reduce startle response and build public trust. Then there's energy. VTOLs are heavy on power. Charging has moved beyond the depot model. Some cities use rapid swap battery hubs, others harness centralized high-power tether stations near landing pads. On longer routes, hybrid models combine small combustion or fuel cell range extenders with electric lift motors. The balance between noise, emissions, and range is an active design trade-off. Safety comes first. Autonomous deconfliction systems allow VTOLs to negotiate right-of-way in milliseconds, using both local sensors and shared telemetry. Emergency descent paths and automatic safe landing protocols are enforced by software, and regulators require multi-layered redundancy. If one motor fails, the craft can glide to a planned safe zone. These are the same reliability principles that have protected commercial aviation for decades.